Okay, lab one, charge tape. I'm Kepner. I'm gonna go pretty fast because I only have 5 minutes, so lock in. Introduction. All right, so we're gonna investigate the interactions of like charges via tape. Basically, we treat tape as a point charge, and then we're just trying to see basically how the charges of two charge tapes interact. So you'll see as a result, when one tape is brought close to another, it kind of floated in the air. You'll see the setup for that. One was basically placed on top of two erasers, and then one was placed below it, and the middle of the tape kind of floated up because of the repulsion. Both tapes have a negative charge, but I will address that in a little bit. So the main physics principles here are that net force Newton's first law. Basically, when the net force is zero, there's no motion, or objects in motion will stay in motion. So nothing changes, no acceleration. Gravitation, F equals mg. That is just going to be the force of gravity on something. Electric fields, this is the basically field that we're using. And then point charge approximations, I just covered that. Basically, we're treating the tapes as a point charge. Now, the procedure. The top tape was set up between these two erasers right here. And then while it was on there, it was charged by ripping it off the table. And then there was a little bit of slack, so we put the erasers kind of close together. So there was a bit of slack hanging down. Um, then we charged this bottom tape and kind of put it close to the bottom so that the two fields could interact, and then they pushed to the top. Calculation process. So, started with the tape density at 1 gram per meter. The tape was 13 centimeters long, 0.13 meters, meaning that it is not that many kilograms, as you can see. We use that force of gravity equation I just brought up to then basically calculate with mass times the gravitational constant 9.81 meters per second squared. Um, acceleration due to gravity, as this many newtons. We assumed that Fg and Fe were equal. Um, this is because the tape was not actually moving when it was floating. It was just kind of sitting there. And then we also assumed the charges were equal. And this was so that the forces would balance out. Um, Down here, the separation distance we measured between the two tapes at the very lowest point was 1.5 centimeters, or 0.015 meters. And right here we are using the force equation, F equals QE, or the force of electric field equals a charge times, sorry, yes, times that field. And so we're kind of taking the gravitation here, multiplying it all by um, K, which is a weird little 1 over 4 epsilon pi, terrible constant, spitting out this charge. System, two pieces of tape, surroundings the Earth, total conditions, separation is 1.5 centimeters, and tape length of 13 centimeters. Um, Code. So I basically just hard coded the gravity vector and the electric field and electric force vector were created by using this electric field function in lab 0. And then the vectors were scaled back for visual purposes. The simulation looked like this, with electric field or force right here, 2 point charges, and the gravitational force. Now, what if? What if the electrons have positive charge? Who cares? There's still repulsion going on, and it doesn't really matter because even if they're both positive, they're still going to repel. Um, why is it important to hand the charge tapes as little as possible? Charge will get transferred from the tape to your neutral hand. The tape is charged, your hand is not, and so that's kind of an issue. Loki. Possible error. So there's some similarities between the model and real life. Obviously, the force is canceled in the model because we set them equal to each other. But in real life, the force is canceled because the tape was not moving at its highest point. You'll see that right there, where it's kind of stationary, a little hump in the ceiling. Um, and so the differences are we assumed that the tape was a point charge. I mean, in real life, it's a very large collection of them, so it doesn't really like equal. But I don't know, maybe in the future, in some lab down the road, we will investigate it as not a point charge. And so obviously human error in measuring separation distance or in charging the tapes, they can be slightly different. Have a good one.